Hello, my name is Matt Dooley. I'm the Vice President of Deployment at TeleWorld Solutions. I'm proud to say that earlier this year, TeleWorld Solutions became a wholly owned subsidiary of Samsung Electronics of America. A little bit about myself. I started my career in 1989 working for Cellular One Chicago. During the PCS evolution in the mid-90s, I transitioned over to Primeco, which was eventually acquired by US Cellular. Over my career, I had many different roles, from device installation to network operations to RF engineering, system performance, deployment, and I eventually finished my career at US Cellular, where I focused on RAN planning and device engineering. In 2014, I joined the leadership team of TeleWorld Solutions, where my current focus has been growing our deployment organization. I feel very lucky and privileged to be part of the wireless industry, and I could not be more excited to help with the rollout of fifth generation networks. My presentation is titled Tools for Success in a 5G Economy. I will be discussing some of the opportunities and challenges with 5G and how the team at TeleWorld Solutions is approaching them. I hope you enjoy the presentation. With the global market opportunity exceeding $13 trillion over the next 15 years, 5G will add millions of jobs to the global economy, both directly to our industry and indirectly to many others. From improving the quality of life through AR and VR, ushering in new industries, and improving manufacturing, 5G will be the key driver of economic growth for the foreseeable future. Interesting enough, based on this research, a large portion of this money is towards the manufacturing industry, taking the telecom industry in areas never seen before. Using manufacturing as an example, 5G promises to meet the critical real-time needs of the manufacturing industry. Diversity in use cases across different market segments will require new tools, new processes, and skill sets across our industry. In the case of manufacturing, improving operational efficiency seems to be a logical goal, but it also has great potential to improve workplace safety and increase quality standards through the use of increased automation and real-time feedback. The evolution of wireless has grown well beyond the days of basic circuit switch voice or simple text messaging. I can remember the days testing 2G and being amazed at exceeding 100 kilobits per second. Then with 3G, we improved by an order of magnitude exceeding 1 megabit per second. Then with 4G, it's not uncommon to see speeds in excess of 500 megabits per second in our urban areas. And not to mention that our data network now carries all our voice traffic. Today, we take being connected for granted. We stream our music, we watch movies online. Social media are commonplace in today's society. Today, many of us work remote. Our kids go to school online. All use cases we never really thought of, but are still generally geared towards basic connectivity. 5G is still going to be all about connectivity, but there's unlimited dimensions on what we are connecting, how we're connecting it, and how that connectivity is going to be used. From automated driving to smart cities, improving industry, and AR and VR improving our healthcare, our training, and safety. All of this is going to add complexities to today's networks and tomorrow's networks across the board. When we take a snapshot of the 5G lifecycle, we can see that 5G is going to impact many industries, if not all. From manufacturing to info and communications, retail, public service, agricultural. Use cases are going to be defined by industry and by solution. So in the case of industrial, is the equipment being deployed in a factory? Is it office space and enterprise? Is it an agricultural solution, commercial solution, smart city, just to name a few? From a design perspective, we need to consider what type of spectrum we plan on using, whether the solution is in building or outdoors or a hybrid of both. And then what type of connectivity does the solution require? Direct fiber, where is the edge going? Where is the edge located? What does the connectivity matrix look like for the solutions being deployed? As we get into deployment of 5G networks, we will still follow a general traditional model. Systems need to be surveyed before deployment, permitting and zoning, A&E, and of course, tracking of milestones during the deployment process as we get into hundreds or not thousands of systems. And then the closeout package to make sure that the systems that were designed meet the expectation of both the end customer and the company who's deploying the equipment. From an optimization standpoint, of course, we need to still monitor coverage and whether or not the expectations were met, but we're going to have more stringent requirements associated with capacity, throughput, and latency. And of course, reliability, as these networks will be dependent to run critical communication infrastructure, especially in manufacturing, AR, VR, and some of the other use cases that we talked about. From a support perspective, the skill sets to manage and maintain these networks is going to change. We'll still need to manage KPIs and follow trending for predictive analysis, but this becomes far more advanced as we get into these multidimensional use cases. Break fix, our technicians and our engineers will need to go out to the field to provide system restoral, hardware failure replacement, and technical upgrades that occur, just part of the lifecycle process. And then remotely, these systems will need to be managed for software updates and other items as part of the troubleshooting process. When we look at the realistic view of the 5G lifecycle, when it comes to 5G, each use case is going to define its own individual set of requirements. This is going to lead to customized spectrum plans for both public and private networks, stressing the demands of deployment teams. There are countless types of solutions that will be required to meet the demand, whether that from an in-building solution to hybrid solutions to outdoor-only solutions. During optimization, improving one use case can easily negatively impact other use cases. Managing these systems will require innovation, automation, in every tool we currently have in our toolbox, plus a bunch of tools we haven't even thought of yet. At TeleWorld Solutions, we provide full end-to-end services from engineering, deployment, field services, technology development and optimization and migration, and managed services from NOC monitoring, neutral host system engineering, optimization and maintenance, backhaul engineering, smart city deployments and optimization, as well as staffing. As we assess our process for 5G, we need to look at the same pillars that we looked at for our tools: the use cases, the design elements, deployment complexities, optimization, and management. When we get into the use cases, our processes need to account for alignment with the customer to ensure expectations are met. This is basically telecom professionals are going to need to interface with the end customer at a level not seen before, whether that's in a factory environment, a city environment. It's going to be far more about coverage and performance. The call flows need to be discussed so connectivity and expectations are aligned. This is going to feed into the tool sets that we have, advanced modeling, site selection, and the different connectivity options associated with backhaul, front haul, or mid-haul. Site selection needs to be heavily automated. When we look at the number of nodes or the number of elements we're going to need, automation is the only way this is going to be done in a timely manner. As we get into deployment, our deployment teams are going to have to interact potentially with heavy industry, different enterprise elements, unlike we've seen before. I think many of our teams out there today know how to deploy in-building systems. They know those environments. But the intimacy in which these networks are going to interface with other equipment, such as in hospitals, again, heavy industry, and different environments is going to stretch the skill sets and the processes we have in place on interfacing with those people. Tower installation is going to become more complex as we get into multi-band radios, shared spectrum, and different types of connectivity on top of the tower. And then, the type of equipment is also going to still need to be installed on street furniture, highly compact, and even less than street furniture, potentially in other public infrastructure to provide the connectivity and meet the expectations of the use cases. From an optimization perspective, we're going to need to look at the end-to-end view, and we have a lot of those systems in today's 4G networks. But I would say in the future, these end-to-end views are going to need to be multidimensional. There's going to be different realities based on the call flows. So understanding the need from maybe even the same customer having multiple needs across multiple paths are going to need to be observed. We're going to be well beyond network KPIs that we have today as we look at these additional flows, leveraging crowdsourcing or data analytics to make sure that these networks are not only meeting the customer needs, but we foresee anything coming down the pipeline as far as capacity concerns, degrade in service. Optimization is going to, again, the theme of this is really the multidimensional optimization. From a management perspective, again, understanding the customer's expectations is going to align to great service level agreements or detailed service level agreements, leading to accountability from both the customer side and the operator side. Equipment needs to remain serviceable. As I mentioned before, things are still going to break. But understanding the impact and degrade that happens with this type of equipment or this type of deployment is going to be critical. And we're going to need to remain flexible. We could be put in situations where equipment needs to be repaired and operated on outside the telecom industry, whether that's the customer themselves, third parties, just due to safety, heavy industrial environment, different accessibility depending on where it's going to go. One example of a process flow that we've created at TeleWorld is taking RF predictions, so taking signal requirements and spectrum requirements, and then working with algorithms to determine sites based on OpEx, based on CapEx, based on ease of deployment. As an RF engineer, I always want a site in a perfect place. That perfect place doesn't matter if it's going to take 10 years to deploy. So having algorithms that could adjust the gain, the benefits of getting the perfect site versus the benefits of getting the site quickly. Understanding your front haul options, back haul options, different data set connectivity, access to fiber, access to microwave. You can deploy a perfect site. If you can't get connectivity to it, it really doesn't matter. Maybe there's good microwave options, and then doing the RF analysis on whether or not microwave is a possibility. Having those algorithms and systems in place to work on the dependencies is critical. And then again, talking about crowdsourced data, understanding user density, where the population is going to be, whether the users are going to be, whether they're private users or they're public users. And then, even in a massive IoT environment, understanding where network sensors are and understanding what those link budgets are, potentially having billions and billions of customers in a market, through a sensor network is daunting, but there's a lot of different data sources and different data analytic tools to get us there. So we talked a little bit about process. We talked a little bit about tools. As the workforce grows, we're going to need to find people to grow with 5G deployments and the demand that's going to be put upon us. That's going to involve getting creative from a sourcing perspective. So looking outside the telecom environment for associates, employees, engineers that align with other industry experts, whether that's in manufacturing that I've used as an example, in automation for autonomous vehicles, drones. We're going to need to find engineers and technicians and staff that align with our customer expectations, that understand the languages that they're talking. Leveraging veterans groups, different trade associations, universities, community colleges, trade schools. That's how we're going to grow our workforce to align with the 5G economy. Skill sets, as I mentioned, industry alignment. That's something that I think is common sense, but I don't think even I fully understand the involvement we're going to have with different industries to make sure that these systems are highly integrated, highly reliable, and we understand the pain points that are going to come in that world. And again, getting resources and skill sets well beyond telecom, understanding the languages and the interfaces between private industry. Our training solutions and centers need to evolve. They need to take on different skill sets, different types of people coming into those programs. Safety, I think, coming from a deployment and operations background, safety is always on the front of my mind, but understand the different dimensions of safety issues that could arise by having non-reliable equipment or a poor installation. Those are different dimensions that we're going to need to think through as we deploy 5G networks. And then when we have a highly skilled workforce and we grow that workforce, we need to keep those people with us. Setting clear job expectations, growth planning, understand where our engineers want to be in 1 year, 2 year, and 5 years, and make sure that our engineers and our programs are in a continuous learning environment as the 5G networks evolve. We need to improve our skills, we need to adapt, and we need to overcome some of the challenges that we're going to get that we probably don't even understand that we're going to have today. As I talk about automation and processes and tools, one case study or design approach that we've taken with one of our clients is automating the design and site selection process. We take semi-static data sets, such as grid files, spectrum availability for that client, population density, crowdsourced data, accessibility to fiber, and then a CapEx and OpEx model for that specific client. We apply customized weights, coverage targets, performance targets, prioritization based on area. We can load in tower databases, again, fiber databases, and edge data centers based on the connectivity requirements. We ingest all that data, and that data is just an example. We can ingest almost any data set. And then through weighting and predictive analysis, we can go ahead and create an automated design. This process has allowed us to design hundreds, if not thousands of sites in days, not months. And this is the type of innovation and out-of-the-box thinking that's going to be required to design brand new networks from scratch. This has been a very successful project. We're very proud of this, but it is highly customized based on the needs of the client and the use case that I've been talking about. At TeleWorld Solutions, we leverage our hands-on experience from hundreds of thousands of wireless implementations. We create innovative tools, techniques, and processes that can save you time, money, and aggravation, especially as these systems develop in complexity throughout the 5G economy. From consulting to design, dimensioning, testing, optimization, and deployment, we cater to the full life cycle of wireless technology without an ounce of waste, inefficiency, and diminishing returns. At TeleWorld Solutions, we're always on the forefront of innovation with a future-focused approach. We understand that everybody's problems are unique and they require unique answers that guide you not towards necessarily the best practices of today, but the best practices of tomorrow. Through deployment of wireless networks, setting up and designing customized cores, backhaul solutions, and device testing, we have an innovative approach to today's problems and tomorrow's challenges. At TeleWorld, we are solutions focused. We have over 450 employees and growing every day. We have over 2,000 alum. Our expertise comes from over 200 hours of in-house training in various topics, and our average engineer has 4 years of tenure. We are certified on hundreds of different tools and integrated systems. We've developed over 5,000 internal algorithms, such as the design process that I mentioned earlier, but hundreds of other solutions into reporting, innovation, optimization, and design, creating thousands of hours of efficiency. We have processed over 1 billion data points a day across millions of devices for processing, crowdsourcing, and alternative ways of looking at data optimization. Our mission is to leverage various capabilities in a solution that solves the problems that meets our clients' goals, not only today, but in tomorrow in the 5G economy. At TeleWorld Solutions, we provide full end-to-end services from engineering, deployment, field services, technology development and optimization and migration, and managed services from NOC monitoring, neutral host system engineering, optimization and maintenance, backhaul engineering, smart city deployments and optimization, as well as staffing. I'd like to thank everybody for their time today. Thanks for listening. If you have any questions, my contact information is on the next slide. Have a great conference, and thank you.